What are essential measurements for effective power factor correction? Imagine trying to tune a musical instrument without knowing the notes you are playing. In electrical systems, the same applies to fixing power efficiency. To make sure power factor correction works well, you need to measure specific electrical parameters accurately. These measurements tell us how well the system is using electrical power and what adjustments are needed. First, active power, measured in kilowatts, shows how much real energy is used to do useful work. Think of it as the actual work done by machines, lights, or heaters. Next is apparent power, measured in kilovolt amperes. It combines active power and reactive power, representing the total power supplied by the source. Reactive power, measured in kilovolt amperes reactive, is stored and released by inductors and capacitors in the system. It does not do any useful work but causes extra current flow, which can lead to losses. Power factor itself is a ratio of active power to apparent power. It tells us how effectively the electrical power is being used. A power factor of 1 means perfect efficiency, where all supplied power does useful work. When the power factor is less than 1, it indicates inefficiency, often caused by reactive power. To understand the phase relationship between voltage and current, we measure voltage and current waveforms. These waveforms help us find the phase angle, which shows how far apart the voltage and current are in time. In systems with nonlinear loads like computers or variable frequency drives, harmonic distortion can lower the power factor. Measuring total harmonic distortion, especially of current, helps identify these issues. High harmonic distortion can cause voltage fluctuations and resonance, so it's important to measure and control it. Knowing the load profile over time, including peak and average loads, helps size the correction equipment properly. If the load varies a lot, dynamic correction devices might be necessary. Measuring the phase angle between voltage and current gives a clear picture of reactive power. This helps determine the size of capacitors or inductors needed for correction. To get these measurements, technicians use power analyzers or power quality meters. These tools provide accurate readings of kilowatts, kilovolt amperes reactive, voltage, current, and harmonic distortion. Once you have these numbers, you can calculate the right size of capacitors to supply reactive power locally, reducing the reactive current drawn from the supply. This improves the overall power factor and reduces system losses. Monitoring harmonic distortion is also key. If harmonics are high, adding harmonic filters along with capacitors can prevent resonance and voltage issues. For systems with changing loads, continuous measurement allows for real-time adjustments of correction equipment. This way, the power system stays efficient and stable. In short, the essential measurements for effective power factor correction include active power, apparent power, reactive power, power factor, voltage and current waveforms, harmonic distortion, load profile, and phase angle. These measurements provide the data needed to make precise corrections, improve energy efficiency, and keep power systems running smoothly.